In this video, let's go and look at some of the graphing features that you can do on your calculator. In order to graph any set of data, you're first going to want to enter the data into a list. So you're going to go to Stat, Edit. I've already put some data into my list 1 and list 2. You don't need the same set of data that I have. Just put something in there and make sure they both have the same length, since we'll look at a scatter plot in a minute. And then to get to our plots, remember we're going to second y equals, and we'll press enter for the first one. The first graph here is the scatter plot. You should probably have list 1 and list 2 there already. I'll go ahead and put that. Everything else looks reasonable. And then for all of these plots, remember you're going to zoom 9, which is zoom stat, and that will give you the best window possible. So there's my scatter plot. The other plots that we can do, we never use that second one. The second one is a trend line, but we can ignore that one. We've got our histogram, which is only going to take one set of data, and the frequency is just 1. So we'll look at my histogram of list 1, go back to zoom 9, or my histogram, sorry. So there's my nice little histogram. And then the next two graphs are the box plots. So the one with the little dots is the one that will show you outliers if there's any outliers. The second one will not show you outliers. I would always go with the first one because oftentimes when we're looking at box plots, we actually want to know if there are outliers or not. Once again, this just takes one set of data. List 1 is good. The mark is just going to tell you which, or how it marks the outliers. Zoom 9 again, and my data here does not have any outliers since we don't have any starred points on the outside. Remember with your box and whisker plot that this middle line of the box is the median. This is the lower quartile, so that's the median of the first half of data. This is the third quartile, the median of the upper half of data. And then you have your lower, or your minimum and your maximum value when there are no outliers. And then the final graph that we're going to look at is that very last one. This one is the normal probability plot. Remember that we can use this to check and see if a set of data is approximately normal. And what we're looking for in that is we're looking for a straight line would tell us that our data is approximately normal. So we'll use list 1 here to see if list 1 is approximately normal. It doesn't matter which axis your data is on, so just pick one. And we'll go back to zoom 9. And look at that. I have a very linear looking pattern here. So I would say that my data in list 1 would be approximately normal. So the normal probability plot is one of those graphs that you can look at when you're trying to see if a set of data is approximately normal, especially if you're doing a hypothesis test and had fewer than 30 data points for the mean. Let's go ahead and see what the other things that you can do with the list are. So when I go back to my list here, when I go back to list, if we scroll over to calculate, then this is where we can calculate the one variable statistics. So let's go ahead and put just list 1 in here. If you're on a TI-83, then you're just going to type in list 1 at this point and press enter, or whichever list you're working with. If you just press enter, it's always going to just use list 1, so be careful if you're using a different list. And calculate. And this gives us our mean, our standard deviation, our quartiles. If we scroll down, we've got the first quartile, the median, the third quartile, the maximum value. This is giving us some nice summary statistics. The important thing to remember here is which of these two standard deviations are we using. We're always going to use the first one. That first one is representing the sample standard deviation, and almost 100% of the time we're working with sample data. The second one, seen as it has a sigma, is working with a population. So if you actually did have the entire set of data for a population, then that second value is the one you're going to want to use. The second value should always be smaller than the first one, and so we want to go with that first one. Okay, so if we go back to stat and calculate, we have two variable stats, and so this is going to take toList in there. So we can have list 1. I don't have any data in list 4, so let's put list 2 in there. And if I go to calculate, this is going to tell me all of the same information that I saw before about list 1. So that's all the X information. It also gives me all the information that I needed about list 2, that's all the Y value stuff. And then it gives other information about the combinations of the X's and Y's, so what happens if I multiply them together and add them up. We keep scrolling down. It just gives us the minimum X and Y value. So this could be useful if you had to write the equation of a regression line by hand, which you're really not going to have to do. So that one, the two variable stats, is not as useful for us. The other thing that's going to be useful is the linear regression line. It doesn't matter if you choose number 4 or number 8 here. They just have a different format for where the slope is, but they're going to give you the same final answer. So we go number 4, we've got my X list is list 1, my Y list is list 2, and I press calculate. That is giving me the equation for my regression line. So my slope is 0.5 and my y-intercept is 13.5. The one thing that we oftentimes want to know when we're doing linear regression is we want to know the R-squared value as well. If you've reset your calculator since last semester, then your calculator, like mine, is not giving you R-squared, so you have to turn that on. To do that, go to Second Catalog. And we need to scroll down to the D's, so I'm going to press the X inverse button here to get myself down to the D's, and then we have to keep scrolling. We're looking for diagnostic on. Okay, there we go. Whoops. Maybe go back up. Okay. Well, eventually I'll get back up to there, and hopefully you have already found diagnostic on. Okay. Okay, there we go. Press enter again, and then when you go back to your regression line, not changing anything here, we should be getting, now we're getting R-squared and R, which is good. And remember that R-squared is telling us the percent of variation in the Y values, that can be explained by the X values. R is just telling us the direction and strength of our linear relationship. So in this case, our R value is pretty small. It's close to 0. So that tells us that we have a pretty weak but positive association because R is positive.